All right, hello people watching this video. We are on the notes for section 2-3, but we're on the back side. I'm going to do a little bit of a recap on the front side, just to kind of get us up to speed, and then we'll do most of them on the back side, but not every single problem on the back side. So I'll kind of pick and choose which ones we kind of want to do. Okay, so on the front side, the main thing is, and the hardest thing, is developing the equation to begin with, right? And then after that, just figuring out how to solve. So like on example 1, we got it down to something that was like y squared, y, and a number. And so to solve that, we can plug into the quadratic formula and get an answer to pop out, okay? But then when we did some, like here, we didn't even have to plug anything in. We just solved for h. We divided by 2, solved for h, the square root of that, and we got an answer. But like example 3, we ended up with something that looked like this, and we're not quite done with this problem, I don't think, right? We got to this problem, and we're trying to solve for s, right? Okay? So we've got that thing going on. No, we're not done. We're trying to solve for s, and like, how do I solve that thing if s to the third power is like my highest power? Like, what can I do? What? Yeah, put it on your graphing calculator. You guys can't see this because I'm not recording the correct way, but the people who are in class can see this. Hopefully, maybe. And let's go to here. All right, so I'm going to go to my y equals, and I think I typed this in wrong the other day. Okay, x to the third power plus 120,000 minus 6,000x. Okay, and then I went graph, and it looks like that. I've zoomed all the way out. My window was like really crazy wild. Okay, take a look at my window. Negative 100 to positive 100 on the x. Okay, so if you're doing this in class, we went from x from negative 100 to 100, and my y's went negative 10 to 10. I just stayed negative 10 to 10 on y's. And what the graph looked like is something all the way over here, and then he went back, like he must have looped around and gone back up, and then he went back down again over here. So we're looking at these three places, right here, and right here, and right here, except not quite.
What's your y's?
My y's, I went from negative 10 to 10. You could go negative 1 to 1. It doesn't matter, just as long as we can see the x-axis, right? So I'm looking at those three places, except one of them I don't really care about.
Middle.
No,
No,
wrong.
far left.
Why far left?
Because it's not on the.
What is this
right
number
side.
going to be?
Huh?
What's this number going to be? Negative. And we're looking for a side length of a box, right? We're not going to have any sides that are negative, so that's going to be an error of an answer. Okay, so we're looking at those two places. All right, so if we zoom in, I'm going to go zoom. Okay, if you're watching this video, you might not be able to see this very well, or you might not be able to see this at all. I'm zooming in. Okay, somebody zoom in on the, do you guys have this graphed or no? No? Okay. I was going to say somebody else zoom in on the very right one, but anyway, whatever. I have on the leftish one or the middle one, 21 point, let's go 7. 21.7 for this one. Okay, now I'm going to zoom out.
And you're gone. Is that pretty boring? I know that's how I do that other
Ah.
game where you get like the slope and everything. I don't know how to do this.
What are you trying to do?
Number 2.
Oh, don't worry about that. Worry about the problem first. The other one is at about-ish, like 64.2. Okay, so it says, if the surface area of a box is 6,000, what are the dimensions of the box? So we can have an S that is, I'm going to put it over here. If my S is 21.7, then what is the height of the box? We'll figure that out here in a second. And if my S is 64.2, what is the height of the box? Both of those will give me a surface area of 6,000. All right, but we need to figure out the height. Okay, I've got a bunch of stuff going on this paper. How can I figure out the height from there? I have two things for S. We looked those up on the graph. We got those. How can I find the height? What? What? Plug in where? I see like a guy over here that says h equals 3,000 divided by s squared. We could do that, right? Okay, so let's plug in 21.7 in there first. Somebody do that. I'm not going to get the calculator back out. Somebody take 3,000 divided by 21.7 squared.
Is that 30,000?
Do that really quick. 30,000. 30,000.
30,000.
Divided by 21.7 squared. I think it's 21. Yep, 21.7 squared.
It's approximately 63.7.
63.7.
Yeah.
63.7. Okay, now plug in instead 64.2. 64.2. We're solving for H. If those are my two different S's that we can have for combinations, we're trying to figure out the height.
Oh.
7. Wait, what?
7.27.
Yeah.
7.27. 7.3.
2.8.
3.
Round.
Sure. So I could have this combination of a box where like the base is a little bit wider, or excuse me, the base is a little bit narrower because this is my base and my height is really tall, or I could have a very wide base and my height is very narrow, like it's not very tall, right? And both of those will give me a surface area of 6,000 but a volume that is 30,000. Okay, incorporated those together, right? Okay, so the steps here: make two different equations, plug one into the other, and then solve and graph and find your points where they touch. Okay, like what we were doing in the first section of this chapter, right? Plug them in and solve for your things, right? Those are going to be the hardest ones. I'm not going to give you very many of those, if at all, right? Okay, moving on to the backside. There's a little piece that I kind of covered up over here when we're talking about interest. So this is the next thing. This is interest. INTEREST. Do you need me to go back up? Interest, and this is simple interest, not compounding interest. Simple interest. The interest is found by taking the principal times the rate times the time. Okay, so write that at the top of this paper. Simple interest is principal, rate, time. That's it.
Have we done this before?
Principal times rate times time. Yes, we have. At some point. Not in this class yet, but we've done it before. Yeah. Okay, simple interest. Later on we'll talk about compound interest and you'll have to do stuff with that. But the interest is, what's P stand for? Like, what is principal?
I don't know.
What is principal?
You're like starting.
Your starting amount.
Yeah.
Starting dollars. Whatever you have. Your rate is your interest rate, and T is your time, usually in years. Okay? All right, so here we go. We're stock and savings returns. We have to do some configuring here. This one's not terribly hard of a problem, but setting it up is solving it's easy, but setting it up is a little bit difficult. A high-risk stock pays dividends at a rate of 12%, and a savings account pays 6% interest. All right, so we've got two different things going on here. We've got stock over here, and we're at stock, and we're adding that to our savings account. Okay, now. Stock, yes, it gives a rate of 12% per year, but stock is a little bit like, it can fluctuate. So I might go bankrupt in my stock, right? Like sometimes I'm winning big, sometimes I'm losing big, right? So 12% per year, it's going to give me, on the good years, it's going to give me 12%, but I might end up losing money. But they're saying this year I'm getting 12% per year for stock, and I have also money in a savings account that's 6% interest per year. All right, so here's the deal. I want to add those two together to give me a $9,000 total investment. So maybe I put 3,000 in one and 6,000 in the other, or 1,000 in one, 8,000 in the other, right? To get, let's see, should be put in stock, and how much should be put in savings to get an average of 8%, right? So 6% one, 12% the other. I want an average to be 8% of that 9,000, right? I want those percentages to average out to be 8,000, okay? So here's the deal. I'm going to say equals my total investment, right? Okay, good? All right, now, here's the deal. We are putting this in per year, okay? So the thing to note is that my time is going to be 1. So I really don't have to consider the time in there, right? Okay? But what I want is my interest in stock plus my interest in savings to be my interest total, right? Okay? And the way that we calculate interest is principal, rate, time. So I have principal times rate times time of my stock plus principal times rate times time of my savings equals principal times rate times time of my total, right? Now we just said the time is going to be 1 for each one of those, right? So we really only have to do principal times rate, right? Okay, good? Yes?
You put 9,000 in for each of those?
Now, 9,000 is the total, so we're going to put the 9,000 over here for principal, right? And I want that rate to end up being 8%. So I'm going to do 0.08. I'm running out of room. 9,000 times 0.08, right? Okay. Now I'm going to do my principal times my rate over here and principal times my rate over here. Rate for stock was 12% or 0.12. Rate for savings was 0.06. Okay. Now here's the deal. I don't know how much I'm putting in each one, so I have to put a variable. What would you like to put? X. Okay. I'm going to put X amount in stock. How much am I going to put in savings then?
The rest of that.
The rest of X. How do I find what the rest would be? Subtract it from.
X.
So I'm going to put in here 9,000
X minus 9,000.
minus X. It'll be 9,000 minus X. Not the other way around. Yeah, does that make sense? Okay, and then I just solve it, right? So what is X times 0.12? I'm just going to write it as 0.12X, okay? What about this guy right here? What can I do with that to simplify that? Distribute. What's 0.06 times 9,000? What's 6 times 9? 54, so 540. Okay, plus 540. And then minus
540.
0.06x equals 9,000 times 0.08. 9 times 8 is 72, so it's either 72 or 720 or 7,200. We've got to decide which one is
720.
720. Okay, all right, now we've got how many pieces going on here? 1, 2, 3, 4. Let's combine. What do we got?
Add the 720 in.
Okay, I'm going to subtract the 540. Okay, subtract 540. And that will give me, I don't know, 180. 180. Okay, and then what's 0.12x minus 0.06x? 0.06x. Okay, solving's easy, right? Divide by 0.06. How much money are we putting into the x?
3,000.
3,000 into the x. Okay, now 3,000 into the x, right? Which one was x? Was x stock or was x savings? Stock. X was the stock, the number we put in for stock. Now, we could have technically done x here and 9,000 minus x over here, right? And that would have been fine. We would have gotten a different answer, but we would have, solved it the same way. So I'm going to say stock is going to be 3,000. And then savings. Well, how much are we going to put in savings then? 6,000. Yeah. So after you have the equation set up, it's not too hard, right? Principal times rate, principal times rate, principal times rate. Given that your time is a year, right? Make sense? Good? So, solving not too bad, yeah? All right. All right, we're going to do example 5 because I think maybe you have one like this. Distance equals rate times time. Have you dealt with that in like a science class? This is a good one. Distance equals rate times time, yeah? Distance equals rate times time. All right, here we go. A pilot wants to make an 840-mile round trip from Cleveland to Peoria and back in 5 hours flying time. All right, here's the deal. So we're flying over. We're coming back. Okay? Things that are going to stay the same. Shh. Put the balloon away. Things that are going to stay the same. If it's an 840-mile round trip, does that mean that it's 420 there and 420 back?
Yes.
Okay. If it's 5 hours flying time, does that mean it's 2.5 hours there and 2.5 hours back?
No.
Not necessarily, because you could be going faster
Yeah.
or slower against the wind, with the wind, that type of thing. So not necessarily 2.5 each way, right? But we do know that the distance is going to be the same, right? That should make sense. Back there and back is both 420, okay? All right, so there will be a headwind of 30 miles per hour going to Peoria. So that means headwind. Is it working in my favor or against me?
You head on.
It's hitting me, which makes me go
Slower.
slower, okay? So basically we're going to be subtracting 30 miles per hour to whatever my speed is, right? Whatever. It's fine.
That's not how that works.
I mean, yeah, kind
How
of.
does it work?
You can even go faster if you have a headwind.
What?
Hypothetically, you could go faster if you had a headwind.
Explain. Yep.
No.
How does that work?
I don't really want to hear this.
Lift and fall and use gravity as
The more air that goes under your wing, the more lift you get, okay?
That's pretty far.
The more lift you have, the higher up you have, the more potential energy you have. So if you go down, then you can
We're not wanting to go
your
down.
terminal
You're
velocity.
being
You
silly.
can
All
go
right. Anyway,
faster.
Convinced.
So you have
and it is estimated that there will be a 40 mile per hour tailwind. What does that mean? 40 mile per hour tailwind
Plus 40.
coming back. So we're gonna be adding 40 to my rate,
So,
right?
Plus 10.
At what constant engine speed should the plane be flown? Distance equals rate times time. Distance equals rate times time. Remember this, right? Okay. The one thing that we know is that the distance going is equal to the distance coming back, right? That's the only thing that we know. The distances are the same, but distance is rate times time and rate times time. So that means the rate times time going and the rate times time coming back should be the same, right? Okay, because the distances are the same. All right, so here we go. Let's do. I remember solving this last year, and then they didn't do the same thing as us because they have weird things going on. Okay. All right, we know that it's 5 hours flying time. But then we know that our speed is going to be increased by 40 and reduced by 30.
X plus 40, X minus 30.
Right. I mean, so you could do our rate, but then there's a problem because time is going to be like using a different variable.
X minus Y. Or Y minus.
Right, but we don't want to use two different variables.
I think we still.
I wanted to say they solved for time and they did distance divided by rate.
Yeah, you did, right?
Yeah, that's what they did. Okay, yeah. Let's do this. Okay, so let's do this. Yep. I got it. Distance equals rate times time. If I divide the rate over, distance divided by rate is equal to time, right? Let's look at it. Let's look at it that way. Okay. All right. So hold on just a moment. Distance divided by rate plus distance divided by rate equals distance divided by rate over here, or time. Okay. So I have like going, then I have coming back, and then I have my total time is 5. Is this making sense at all?
Yeah.
Okay. Distance, so we've just rearranged this equation to solve for time. Time is distance divided by rate. So going versus return or versus coming back, adding those together, it should be a total time of 5, right? Okay, what's the distance going? 420 is the distance going. Okay? And the rate going is going to be x going is minus 30. Okay? The distance coming back is still 420, but the rate now is x plus 40 equals 5
Do you cross multiply?
total. No, because they're not on the same side of the equal sign. Yuck.
You
Yuck.
So mature, wouldn't that just be distance over velocity?
can you add them up?
Yes.
That's just the.
What?
Can you add those?
We would have to find a common denominator. How do I solve this? This guy plus this guy equals 5. How can I do that? Like finding a common denominator? Maybe?
Jayton, the sad thing is we've already done this once. You've taken a test over this.
This guy plus this guy equals 5. Ugh. Okay. So let's do this. X minus 30 times x plus 40. We'll just make it all a common denominator. X minus 30 times x plus 40. Here you go. I know. I'm sorry. 420. All right, the first one. He has an x minus 30, but he doesn't have an x plus 40. So we got to multiply by x plus 40. Yeah?
Yeah.
Does this make sense? Okay. The second one we have to multiply by x minus 30. Okay. Now the 5, we want it to have an x minus 30 and an x plus 40. So he has to be multiplied by both of them.
Can't
Right?
the bottoms just go away now?
Yes. That's the nice part. Bottoms cancel off, and then we just multiply stuff through. Okay. So our common denominator, x minus 30, x plus 40.
I have a question.
Yes, sir.
Do they do this when you're at the flight station and they're like,
Yeah.
Trying to figure out.
There's a computer that does it for it.
Oh.
Yeah,
So we're
I
never gonna be
mean,
doing
you
this.
know, but somebody had to design that computer, and
Well,
what happens if
what's
it
the
fails? What happens if all the computers go down and you're like, I don't know, this plane's gonna get here somewhere between 7 and 9 hours from now.
Some guy just walks in there and fixes the computer, and then when you're back,
Yeah.
you might have to delay for.
Well, you could be that guy.
For technical
You could be that guy. All right, 42, 420 times x is 420x. Write this down. What's 420 times 40? Help me out. I don't know.
What you got in your pocket?
I would say 16.
16,800 plus another 420x minus 420 times 30. What is that? 12,600. There you go. Equals these two. If you FOIL that, is x squared plus 10x minus 1,200. If you FOIL the x minus 30 and x plus 40, because I need to use both of them, you'll get x squared plus 10x minus 1,200, yeah?
Yep.
Now, multiply it by 5. 5x squared plus 50x minus, what's 1,200 times 5? 60? 6,000. Ah, no.
That was 600.
No,
Are you
it's 6.
recording this?
Yes, I am. 6,000. There you
It
go.
doesn't have the recording bar at the bottom though.
Yeah, it does right there.
Oh, it does. Nice.
Yeah, nice. Okay, all right. Now what? It is really confusing.
Okay, combine like
Okay,
terms.
combine like terms. What's 420 plus 420?
820.
840. Nice try. 840x. Okay, what's 16,800 minus 12,600? Plus
Don't ask me.
4,200
Yeah, that thing.
equals 5x squared. We're almost there. Now it's not too bad.
Humans average attention span.
It's like 5 seconds.
8.
Okay, now what?
8 seconds?
9. Yeah, 8.
It's 8.
Oh.
You're both wrong. Anyway,
No, I'm not.
we're not talking about
Look
that
it
right
up.
now. I'll tell you what the
I'll bet
answer
you
is.
$5.
No, I'll tell you what the answer is.
What?
I'm not gonna tell you right now. Okay, let's do the thing, and I'll tell you what the answer is later.
I'll tell you what it is, but I'm not
Well,
gonna
guess
do it.
what? In about 5 more seconds, I won't care because my attention span is gone.
Cool. Okay, whatever. All right, now what?
Continue.
Let's move these to the other side. 0 equals 5x squared. What is 50 minus 840?
Not 790.
Negative 790. X and minus the 4,200 from the 6,000. Negative 10,
20.
200. Oh my gosh, we're almost there, guys. Now what?
Do I have to
It's a
write
quadratic.
it down?
Formula.
It's a quadratic.
Oh my gosh.
Equation.
Let's divide by 5. We're almost there.
We're all in
X
this. You said that
squared
5 minutes ago,
Minus 1. That's because you guys aren't helping me. 1.
158.
58x. There you go. Perfect. Minus 2, 0, 4, 0. 2040. Check me.
I bet you're wrong.
Ha.
It's 2040. Negative.
I had negative 2040. All right, now what? We're almost done. Almost done. This is a simple trinomial. What can we multiply to get this, but add to get this? I have no idea.
No.
It's not? Okay. Should we do quadratic?
No.
Let's quit.
Or you could plug it into your calculator and tell me what you get.
What is
Do
that
it.
one thing, Lucas?
Do it.
What?
X equals.
Math?
Math and then go up 1.
Yeah, yep.
Go for it. Do it. Tell me what you get.
Yes, man.
It probably does break down as a simple trinomial, I think.
It probably does. But
I don't know, but I don't want to do it. X equals what? Plus and minus something.
You can just plug it into the quadratic formula. It's faster, to be honest.
Yeah, it might be. Did you get an answer?
No, I didn't do it.
Oh, well. Then how do you know it's faster?
I'm done with, not done with the homework yet.
Negative 12.
But it's too much, I'm too much of a
Plus minus 12?
to do that.
You're wrong.
I just got negative 12.
What's the positive answer?
It only tells you the positive. It only tells you one answer. That's why you have to put it in the quadratic formula. If you're doing a trinomial.
That
if
stinks.
you're doing
Okay,
a
well,
quadratic formula,
It's negative 12. So we know this breaks down to x plus 12 and x something, right? What's 2040 divided by 12?
X minus 12.
You said it was negative 12 as an answer,
170.
right?
Oh, yeah, you're probably right then.
X plus 12.
170 and 12. Negative 170, positive 12.
Negative 170, positive 12. Awesome. Look at that. So our answers are negative 12, like Jake said, and positive 170.
Yep.
Okay, so we got two answers. What is x even like representing?
Are we still on the
Yep,
plane trip?
we're still on the plane trip.
Okay. The constant engine speed the plane should
The constant engine speed that the plane should be set at, which is a really low speed. Like, are we falling out of the sky?
fly at like almost 60 miles an hour, depending on the
I mean, you know, like we're just not flying very fast. Like, you know. But negative 12 is not an answer. X equals 170 is that means that going, it's going to actually feel like we're going 140, but coming back, we're going to feel like we're going 210, right? Because of that going, you know, toward the wind against the wind. Yeah.
Difficult way to average two
'Kay.
numbers.
Good.
Like a really difficult way to just average two numbers.
But it's not though,
Never do such
because
a
it's not the average.
Hey,
I
ma'am.
know, but like it kind of is.
I mean, kinda, but like, yeah, kinda.
Oh, you.
Ish.
It's just-
Hey, I'm.
All right.
Hey, I got a question.
Yes, sir.
So what's the average attention span?
I'm just wait. We're not done.
What?
Because like this is a lot.
I thought you
Um,
my attention span is.
All right. Let's skip down to problem 8. Last one.
Thank you.
Skip down to problem 8, and we'll be done. A car radiator contains 12 quarts of fluid. Like that is the max. This is the total. 12 quarts of fluid. 20 of which are antifreeze. How much fluid should be drained out and replaced with pure antifreeze, which pure antifreeze would be 100% antifreeze, right? So that the resulting mixture is 50% antifreeze. Okay? So I want my amount total. This is kind of goes up to like our interest rate. Okay? We've got our amount times the concentration. Amount times concentration
I took all my tests.
plus the amount times the concentration.
No, I retook them at 98.
I don't know.
Amount, concentration, adding those together gives me the total amount, right?
Then you have this many times.
Total amount. How much total amount do we have?
12 quarts.
12 quarts. Concentration I want it to be is
50.
0.5. Okay, we know that, right?
Yep.
All right, we have, to begin with, 20% concentration, which is this.
Hey.
We have 100% concentration, or 1.00 for the concentration that we are adding. Okay, yes? All right, and we've got to figure out
Does it say you
what amount we're going to put in each one of these. Because it was 12 to begin with, right? But then what? What are we doing to this thing?
I don't know.
We have 12 to begin with of the 20%, and what are we doing?
so we went to say 12
We're taking some
approximately
out.
Uh-huh.
We're starting with 12, we're taking some out. Do we know how much we're taking out?
Can you drain
Enough to
approximately?
get 50%.
Right, but do we know how much we're taking out?
No.
That's what we're trying to solve for.
Five.
X.
Okay,
About five.
so what should we put in here?
Quarts?
What should we put in here? What should we put in this spot? Right here.
X.
Not X.
Minus 12. 12 minus X.
12 minus X. We're taking the 12 and we're subtracting X out. Okay, then what should go here?
X.
X, that's the amount that we're replacing back in, right? We're taking X out of the 20% and we're adding that X to the 100%, right? Then we just solve. This is kind of like the interest rate problem again, right? Okay, now what? We are on a struggle bus today.
Solve it.
12 times 0.2. What's 20% of 12?
About
Like
What's 2 times 12?
24.
24. So what's 20% of 12?
2.4.
2.4 minus 0.2x plus x times 1 is 1x equals, what's 12 times 0.5?
Oh, you broke it.
12 times 0.5.
12 times 0.5.
Uh-huh.
6.
6. Okay, now what?
2.4.
I'm going to subtract the 2.4 over. Okay. What is negative 0.2 plus 1x?
8.
0.8. 0.8x equals 3.6. Divide by 0.8. X equals, what's 36 divided by 0.8? Or 36 divided by 8? What?
Oh.
9 halves, which is blah 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 4.5. I don't know. Check me.
Yeah.
4.5? No.
4.5.
4.5. Perfect. What's that mean?
And you need 4.5.
Out of the 12 quarts, we're taking out 4.2. We're putting back 4.2, but 100%. Right? Quarts. That wasn't too bad. That wasn't too bad, right?
You just guessed.
Oh, you would have guessed 4.2 exactly. I don't think so.
I guessed
Okay?
5.
Yeah, I don't think so.
5.
Okay? All right. Luckily, 1 through 4 are not too bad for your your application questions. This is your homework assignment. It's not out of the book. It is one of these 4 questions. I'm going to talk through like number 1 real quick when it talks about even integers. Okay? Let's talk through even integers really fast. I don't know what my first integer is. Here's my first integer. We don't know what it is, so let's call it.
Your mom.
2.
No, let's call it x, okay? My second number, which is the next
Less.
even integer. Normally it would be like x plus 1 if we're doing the next number, right? X plus 2. These are my 2 numbers that I'm dealing with, okay? Figure out what those need to look like in example 1, okay? Such that the sum, which means you're adding, the first and twice the second, so 2 times whatever the second number is. You're adding those together, and it should be 76, and then solve, okay? All right, so figure out what those should look like, but that's what consecutive even integers are, x and x plus 2, okay? Good? What's the cube of a number look like?
Third.
To the third power, like x to the third power, okay? Figure out what that looks like. This one you will have to use a calculator for and graph it,
I'm so confused.
okay?
What
Just
does that
you
even
need to
mean?
figure out your equations.
You want-
No,
Just
how
define
did you
the
word
approximate
that?
number.
Find a real number that is 2 larger than the cube of itself.
X is
What does
equal
that
to
mean?
x to the
So like
cube
2
plus
times
2.
bigger than itself,
That's
or
gonna be
what?
2 larger means plus 2.
X is equal to x to the third
X
plus
cubed
2.
plus 2, right?
Look,
This is so
Something is equal to x cubed plus 2,
that's the answer.
okay? Figure out what he looks like, all right? Now then keep going. Number 3 is just talking about length and width of a rectangle and area of a rectangle. How do you find the area of a rectangle?
I don't know. I need help with this one, by the way.
It's length times width.
Base times height or length times width? Okay, what are the dimensions of the rectangle? Okay, write out, like draw a picture of your rectangle. This goes straight back
X
to the question that we had like on example 2. Look at example 2 to do this problem. Okay? This one is going to be similar to I think the plane one. After 3 hours, they are 405 miles apart. Okay, think about this one, number 4. Okay? This one I think you can actually do without writing out an equation. You can just think about it. Okay? It was not too bad. All right, so those 4, there you go. Do the best you can.
Divided by 3.
Attempt it first and then I will help. Okay? But attempt it first.
Hey, by the way, if
There you
anyone
go.
wants the answers, I'll give them to you for $1.